At 6:23 a.m. Beijing time on June 2nd, which would be Saturday evening, June 1st, for folks in North America, the Chang'e 6 lander and ascent module, supported by the Chang'e-2 relay satellite, successfully landed in the pre-selected area of the South Pole-Aitken Basin on the far side of the Moon. Since its launch on May 3rd, Beijing time, the Chang'e 6 probe took 5 days to complete the Earth-Moon transfer and successfully entered lunar orbit on May 8th after a lunar orbit insertion maneuver. Following 2 orbital adjustments, Chang'e 6 conducted a 20-day retrograde lunar orbit flight at an altitude of 200 kilometers. The Chang'e 6 probe consists of an orbiter, a returner, a lander, and an ascent module. On May 30th, Beijing time, the lander and ascent module separated from the orbiter and returner, with the lander and ascent module entering a descent preparation orbit about 15 kilometers above the lunar surface. During the initial phase of the soft landing, the lander and ascent module continued to decelerate, adjusting their orbit height and orientation. Upon reaching an altitude of 100 meters above the lunar surface, they hovered to scan and identify the terrain, autonomously avoiding obstacles. After determining a precise landing location, the vertical descent began, completing the entire process within 15 minutes, marking a critical moment in Chang'e 6's 53-day mission cycle. The Chang'e 6 probe successfully landed in the Apollo crater within the South Pole-Aitken Basin on the far side of the Moon. Previously, only China's Chang'e 4 had landed on the far side of the Moon, specifically in the von Karman crater within the South Pole-Aitken Basin, and both the lander and rover of Chang'e 4 are still operational. After the lunar orbit insertion of Chang'e 6, the first step was to release Pakistan's CubeSat, which transmitted images back to Earth. The lander carried the European Space Agency's Lunar Surface Negative Ion Analyzer and France's lunar radon detector to the lunar surface, both of which are set to begin operations. Additionally, Italy's laser retroreflector will also be deployed. According to the plan, sample collection will take place both on the lunar surface and below it, a process that needs to be completed within 48 hours. Surface sampling is relatively straightforward, but subsurface sampling requires drilling up to 2 meters below the surface, which can be challenging if hard rock is encountered. During the Chang'e 5 mission, hard rock was encountered during the drilling process, resulting in a sample depth that was less than planned. Instead of the targeted 2 kilograms, the mission returned with 1,731 grams of samples. Scientists hope that these samples might indicate how much water ice is trapped in the region for future crewed missions, as well as help explain the origin of the larger South Pole-Aitken impact basin that it sits in and how the Moon was formed. Due to the delay in communications between Earth and the Moon's far side, much of the landing process will be automated, but Chinese engineers can still communicate with the probe using instructions sent using the Chang'e-2 relay satellite, which launched in March this year and is currently in lunar orbit. The Chang'e-1 relay satellite was launched during the Chang'e 4 mission and has exceeded its designed lifespan. Chang'e-2 will not only support Chang'e 6 and future missions like Chang'e 7 and Chang'e 8, but also take over Chang'e-1's duties, providing services to the Chang'e 4 lander and rover. If you enjoyed this video, please like and subscribe to our channel for more exciting content. Thank you for watching.